Hello everyone. In this video we're going to be solving an exponential, maybe a logarithmic, maybe a polynomial, maybe a mixture of all of these equation. So we have a non-standard equation. We have x cubed equals 10 to the power log x, where log is logarithm with base 10. Sometimes Wolfram Alpha, actually all the time, not sometimes, in some textbooks as well, just write natural log as log, which I think is not correct. Anyways, that's just my opinion. It doesn't matter. But in this case, I use it for base 10. Okay? That is important because notice that we have base 10 here, right? In two ways. We'll talk about it. Let's get to work. So we have x to the power something on one side, and then on the other side, we have an exponential with the variable being a logarithm. So it's pretty non-standard equation if you look at it that way. But there are some nice properties of logarithms that we're going to use to simplify the process. So this video will basically focus on those identities. And if I did not forget to include, I think I did not forget, I'll show you a graph at the end, which kind of explains pretty much everything. All right, so we have this equation. How do we solve it? One way to think about it is using substitution, because if you don't know some of these identities, substitution would definitely be a way to go. So I'm going to go ahead and call this log x something. How about y? If you call log x equals y, and don't ask me why, from here you get, because the base is 10, remember the properties of logarithms or just the definition, 10 to the power y. By the way, 10 is invisible here, but just imagine we have a 10 at the base. 10 to the power y equals x. Makes sense? That's how logarithms work. 10 to the power y equals x. This is nice because that gives me something for x as well, and I have x on the left hand side, so I can use that. Great. Let's go ahead and use this and this. So we're going to replace x with 10 to the power y, and then I need to raise it to the power 3. Use parentheses if you have superpowers, like superpower property. And then on the right hand side, log x, remember we replace with y. Nice. This really gives you a good path to the solution without getting into the property. So I really like substitution because sometimes it's good to memorize these properties or know them, but if you don't, there's almost always a way to get it done. So what do you do next? We have the superpower property, so we're going to multiply the y and the 3. That's going to give us 10 to the power 3y equals 10 to the power y. At this point, it's probably meaningful to say that, okay, from here 3y equals y, and y cancels out and 3 equals 1. Nope, that is incorrect. Don't do that. Do not just cancel out just because you can, because that'll give you nonsense. Okay, it's not going to make sense at all. So instead, let's do this. We can kind of subtract something from both sides. Subtraction is the safest way to do. You can also divide, but because 10 to the power y cannot be 0. But let's go ahead and subtract it and see what happens. When you subtract, you can basically factor this out. You can take out a 10 to the y. Inside, you're going to have 10 to the power 2y. Think about it. Y plus 1 equals 3y. That's 2y. Minus 1 equals 0. Now, you're going to be setting each factor equal to 0 by 0 product property. But guess what? 10 to the power y cannot equal 0 even for complex values of y. Right? I mean, if y is negative infinity, but y cannot be negative infinity because negative infinity is not a number. Right? You can say, okay, as y approaches infinity or negative infinity, but we're not taking limits here. We're solving equations. Come on, this is serious stuff, okay? So solutions should be coming from the second factor then. So what do we get? 10 to the power 2y minus 1 equals 0. So you got a couple different options here. You can proceed as follows. First, you can go ahead and set 10 to the power 2y equal to 1. And then from here, you can kind of think about, well, this means 10 to the power y squared, and then from here you can kind of split it up. That's one way to approach it. Another way to approach it is you could factor this, right, using difference of two squares. 10 to the y plus 1, which I like better because it uses factoring, and factoring is really cool. Substitution is nice. Factoring is also nice. You should know it, right? I mean, come on. Algebra is the foundation for pretty much all higher levels of math, and you need to know this. So from here, we get the exact same thing. Let's go ahead and look at the first approach first. 10 to the y is 1, or 10 to the y is negative 1. Cool. What about this? Same idea. So we can just stick with one of these. Doesn't matter. At least you know that both methods are going to give you the same thing. And then what can we do? We can kind of look at each equation separately, right? 10 to the y equals 1. Wait a minute. What is y though? Let's go back. If you forgot, I forgot. Y is log x. Okay, great. Y is log x. So what am I going to do? I just got 10 to the y equals 1, and y is equal to log x. What's that supposed to mean? That just means that y is equal to 0. Y is equal to 0 means log x is equal to 0, and that means x equals 1. Really? Is that a solution? Let's test it out. X cubed equals 10 to the log x. If you replace x with 1, you get 1 equals 10 to the power log 1, which is 0. 10 to the power 0 is 1. Yay, we got a solution. Houston, we got a solution, not a problem. Good. So x equals 1 seems to be a solution, but the million-dollar question is that the only solution? Probably not. I don't know, maybe, because we still haven't looked at this, right? What does that mean? 10 to the power y equals negative 1. Uh-oh, that doesn't look good. Y is not a real number. Why? Like W-H-Y. Because 10 to the power y cannot be negative, unless y is a complex number. In which case, we can write this as e to the power y ln 10. You got it? 10 can be written as e to the ln 10, and then I multiply the y and ln. Sorry, I skipped a step there. I hope you don't mind. And negative 1 can be written as e to the power something. Okay, Euler, let's call Euler and ask him. It's e to the power I times pi, but that's just the principal form. You could probably write like something like 2 pi n to it, right? You can just add it. Or totally ignore n and just set n equal to 0. From here, we get something like y ln 10 equals, let's just forget about the n because I want to keep it simple, like this. And then from here, y becomes I pi over ln 10. But wait a minute, what is y? Y is equal to log x. Okay, great. So this is equal to log x, which means x is equal to 10 to the power I pi over ln 10. Can you simplify this more? Probably, but you don't have to worry about it. Okay, so that looks like a complex solution, but let's go ahead and look at the second method, because I think the second method is very cool. And please let me know what you think. All right, and we might find some different results, and don't worry about it. Just put those two methods together. Hopefully that'll complement, or they will complement each other. Okay, here's what I'm going to do. I'm going to use an identity. And what is that identity? That identity is a to the power log b with base a is equal to b. When a is at the base and a is at the base, they kind of undo each other. Exponential and logarithmic by definition, and you can easily find that, like set this equal to a and then log both sides, and then you're going to get log 10 equals 1. You're going to get x equals a, or a equals x. So in other words, 10 to the power log x is nothing but x, with one limitation. X needs to be positive if you're looking for real solutions, because log x is otherwise undefined. But if you're looking for complex, be my guest. So if x is positive and this is equal to x, what does that give me? It gives me x cubed equals x, and then I can kind of put everything on the same side, factor out the x, use the difference of two squares, factor again, set each factor equal to 0, and from here you're going to get x equals 0, x equals negative 1, and x equals 1. Uh-oh, these two are not positive. We're not going to take them. We're only going to take x equals 1. Let's go ahead and take a look at the graph, shall we? Because we'll finish. I just couldn't say finish. We will finish with that. Okay, here we go. So basically, you do have the graph of, what is that? I forgot. X cubed, y equals x cubed, and you have the graph of 10 to the log x, which is x, but when x is positive. So you're kind of getting that diagonal, but only in the positive region, and the only intersection point is at 1. So x equals 1 seems to be the only real solution. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.